In order to show the amazing robotic world to students, we developed a cute, economical robot for MCore called MBot. With an aluminum alloy chassis, MBot, and the graphical programming software MBlock, students can start robotics projects quickly. We optimized MBot for the classroom. No more annoying USB cables now. Instead, we added a Bluetooth module for remote control. In the future, MBot will support 2.4 GHz wireless solutions to allow for larger classroom teaching. MakeBlock provided 2 power supply solutions for MBot. You can choose 4 AA batteries or 1 chargeable lithium battery as the power supply. The scalability of MBot can't be understated. Combined with the Arduino mode in MBlock, you can translate the Scratch-style program into Arduino code and upload it to the Arduino board, allowing the robot to run offline. MakeBlock provides a smooth transition from graphical programming language to code programming language. The aluminum alloy chassis of MBot is compatible with LEGO and MakeBlock parts. The electronics are based on the Arduino open source platform. MBot frees your creativity, allowing your ideas into reality. Balloon battle, soccer game, the only limitation is your imagination. This is MDrawBot, a 4-in-1 drawbot. In 2012, we brought you the MakeBlock, the next generation of construction platforms. It helps you build your own robot quickly. Now our team has grown from 5 to 50. We're ready to take on something bigger. MDrawBot is based on MakeBlock. It contains structures, motors, pen lift mechanisms, and electronics. Form 1 is MSpider. It's a high-precision robot on a vertical surface, and typically its painting range is huge. The 2-step motors are used to control the position of the spider. Form 2 is MScara. Oh, you have seen that before? MScara could draw wonderful painting on the paper, and if you put a laser diode instead of a pen, it could even become a laser engraver. The third one is MEggbot, which could help you make your own Easter egg. Pretty, And the last one is MCar, the infinite drawbot on the ground. The control part of MDrawBot is based on Arduino, a software that is open source. You could use their own Arduino board as a controller, or you can use MakeBlock Orion, which is an updated version of Arduino Uno. Using the RJ25 cable, connecting is a cinch, convenient, and easy.
MOS is a construction kit for you to imagine, design, build, and play with robots.
We designed MOS using everything we learned from Kubelets. We took all the robotic complexity inside, the microcontrollers, motors, H-bridges, signal filters, the whole deal, and boiled it down to elegant little blocks with simple connecting faces.
There's no complicated computer code or programming or wiring or soldering. You just pick the parts up and you're making robots out of the box.
We used a single button contact to transfer power and data while the ground passes through the steel spheres. All the circuit boards in MOS double as planar wires, delivering power, ground, and data right where they're needed.
One of the coolest parts of MOS is the connection system with these little steel spheres. There are tiny magnets in the corners of each module, and by snapping them together you can create all sorts of joints. With 1 sphere you get a universal joint, with 2 you get a hinge, and with 3 or 4 a rigid connection. The properties of these little fiddly bits let you build some pretty cool kinematic constructions.
The neodymium rare earth magnets are overmolded directly into the plastic during the injection molding process, so they won't ever break out and cause a problem.
We've designed a huge pile of different modules so you can build robots that drive, wiggle, detect objects, grab them, and then react to the world around them. If you snap on the Bluetooth module, you can pair with your phone or computer and remote control or reprogram the modules in your robot.
I think one of the many things that makes MOS really fun to play with is the magnetic connection system. Magnets are magic. It's force acting at a distance. When you snap these parts together, the click, the feel, the magnets, it's really magical. And I could play with MOS for hours on end just playing with the parts.
I can't even look at the camera, I'm so excited. I've never seen anything like this. This blows me away. Just the amount of doors it opens up to just wild creativity. I love the tactile feedback. I love how it feels.
I've always been totally fascinated with this idea of software wrapped in plastic and the integration of hardware and software. And MOS is a great way for somebody to be able to explore hardware and software in a very accessible way with gazillions of different configurations.
Sparky is a simple-to-use, open-source Arduino-based robot. The lowest-cost full-featured robot on the market. And is an engaging introduction to programming, electronics, and robotics.
Sparky is very easy to use and to get started with. Just take it out of the box, plug it in, download our customized Arduino software, and get started with any of our dozens of programming samples. Or you can write your own code in minutes using our online tutorials. We've been conducting pilot classes with elementary and middle school students and have been amazed at what they can do. We are working hard on enhancing and expanding our curriculum for Sparky, improving the lessons and code used in the class. Sparky is easy to use for the beginner,
Yet feature-packed enough for even the most passionate enthusiast or researcher, and is aimed at anyone looking to learn these subjects or to have a comprehensive robotics platform for their own projects and experiments. Sparky includes a servo-mounted ultrasonic distance sensing head, 3 light level sensors,
a 3-axis accelerometer to detect the current angle of the robot, 5 line following and edge detection sensors,
infrared send and receive modules for inter-Sparky communication, and to use with the included remote control, a 128 by 64 pixel graphic LCD.
and 2 geared stepper motor wheels for highly precise measured movement, which, when combined with Sparky's center-mounted marker holder, allow you to do some amazing drawings.
The U-arm has 4 degrees of freedom and laser-cut parts made from acrylic or wood. There are 3 servos on the base to control the main movement of the arm, and 1 mini servo on the top to move and rotate an object by using a gripper or a vacuum cup. The vacuum cup would have enough power to lift and move a full can of soda. With our Arduino-compatible circuit board, coding can be made much easier with the Arduino IDE. Besides writing codes to program it directly, the embedded inverse kinematics algorithms we wrote for the U-arm enables it to be controlled by setting the X, Y, and Z coordinates, instead of controlling the servos directly. Our algorithms also make mouse and keyboard control possible. We have already developed a Windows application, and we are working on the iOS and Android apps as well, so you can control the U-arm with your phone. So no matter if you're a programming master, a keen parent that wants to get your child interested in robotics, or if you're just a robot fan who doesn't know where to start, the U-arm is a great way to learn about robotics.